What all that 4mg sin theta will act here? Then 4mg cos theta. Friction should act up the incline, no doubt, because it has to roll. It has to roll. Then for no slipping, acceleration of center of mass, AC, and let this be alpha C. C is the center of mass of system. If you want to, you bring also the normal contact. Of course, may not be, it's needed here. First, we should calculate the moment of inertia of this one. What we know the radius. We have to get the distance. So if you go back to again, we will. K equal to 4. Okay, yeah, fine. Yeah. K equal to 4 by, yeah, fine. Okay, right. Yeah. First, we'll get the moment of inertia. I think there's only difficult thing. Rest all everything you can manage. Rest all everything you can manage in the problem. Only the getting moment of inertia. So let this be the, what is the radius? Radius is R. If this is R, this is R. So what is the side length? Side length, let it be L. So this will become 4R, 2R whole square equal to L square plus L square. Or this will become 4R equal to 2L square. So therefore L is equal to R by root 2R. This will be the side length. Okay, if you know that, then we can get this distance, because this is what needed for us. To get the moment of inertia calculation, we needed this distance. Call this is Y. So in the triangle, L by 2 Y, and this is R. So R square is equal to L square by 4 plus Y square. R square, L is root 2 R whole square by 4 Y square. R square, this will be 2 is equal to R square by 2 plus Y square. So Y is equal to R by root 2. Now you get the moment of inertia. So how to get the moment of inertia? Find out for any one rod. The net moment of inertia of the system will be applying parallaxis theorem. ML square by 2L plus My square. Multiply this with 4 times. It'll be same, no? I see this will be. So 4 M by 12. L is root 2R whole square. M is, I think this problem is all about only calculation of moment of inertia. Rest all you can manage. 2 will come outside. So MR square by 6. MR square by 2. The net moment of inertia of the system will be
8 ml square by 3.
8 MR square by 3. Okay, that's all. We'll write as usual the typical rotation mechanics for problem. 4 mg, you should not forget. There mg sin theta, if you write it, gone. 4m AC, then F into R is equal to IC into alpha C. For condition for pure rolling, AC equal to R alpha C. So what we have to get the mu, minimum quotient or minimum value of quotient of friction to get that one. First, we'll get the expression for F here. So for that, I think we should eliminate AC. So this equation, substituting this will be, I'll carry on here. So this will become F into R. Moment of inertia, what we got it, 8 MR square by 3. After getting this alpha C, I'll write it as AC by R. So F is equal to 8 MAC by 3. AC value I'll substitute in this equation. So 4 mg sine theta minus F is equal to 4. MAC will be 3F by 8. 4 mg sine theta. This will be 3F by 2. F plus 3F by 2. So F is equal to 8 mg sine theta by 5. No. After this, what to do? What is the maximum permitted friction here? Should be equal to mu Sn, and that is equal to 4 mg cos theta. And we know theta is given 45. Now this friction for pure rolling, what is the requirement for pure rolling? This friction should be less than limiting friction, no? For pure rolling, for no slipping. I'm just wanting to revise that idea. That's why I pick up for no slipping. F should be less than or equal to the limiting friction or maximum static friction. So this will be 8 mg sine theta by 5 should be less than equal to mu s n. What is n? N should be equal to 4 mg cos theta. I think now almost we are at the end. So theta is 45 degrees. So this 8 by 5, 4 mg. I think, okay, this is, I'm missing. So this will become 2 by 5. So what is value of mu s? Mu s should be less than or equal to, no? So mu s is what? 2 by 5 or 0.4.
Sir,
Okay, yeah.
we can use mu minimum equal to tan theta by 1 plus mr square by AC now, sir.
Directly you can go for it. Just I wanted to make everyone to revise once again the basic idea from where that condition formula has come. The numerical is all about no you may, so there's a very best problem I feel like. Okay, you brought it. Now what happen? I'll apply a force. You start analyzing. So like this, like in a massless ring, a frame will be put, or I'll bring a cone, whatever that one. No, the different objects I can bring. I can inscribe if there's a thing. I can even put a cone, no, or a triangular plate. This will have a mass m. This is massless ring, light ring. This small idea is enough. Then I will project with a velocity v0. After what time it will attend pure rolling. So this will be more troublesome. That's why what you learned, no, this is what you should able to multiply it. Got the idea, no? So that we need not to bother. Only thing, getting the moment of inertia of the object which is there inside that ring is very important. That if you get it, again we can continue the problem. Or I can apply force instead of giving velocity. I'll apply force. I'll apply force at highest point. So many ideas will start coming. Then where the friction will act towards right to towards left. What is the major problem? It is not a ring where it will become at highest point friction will be forward. I think we have to be very careful here. So first, the moment of inertia of this plate has to be determined. You have to solve the problem. You assume the friction. If you get positive, okay, you assume in right direction. If you get negative, then you have to change the direction. So here I'll just assume it to be like this. Then I'll proceed into the problem. I'll solve it. If I get positive, what I assumed is right.